So now we're going to look at application of a matrix in the input-output model. An input-output model represents the flow of money in an economy, primarily through the connection between industries. To what extent are different industries buying and selling to one another in a particular geographic region? There are two types of economy that we will look at today. One is the open economy, where industries sell to meet intermediate goods demand, meaning to say they sell to other industries which will use those goods as their inputs. And also the industries sell to the final user, and this is called the final user demand. So we can describe that into X, which is the output of the economy, is divided into intermediate goods because they are purchased by other industries, and also final user consumption, which is what we call D. So the matrix operation will be X minus AX equals to D, X, which represents 1. We use the identity matrix. I minus A equals to D. And to solve for X, we need to find the inverse because we cannot divide, and multiply with D. So let's take an example of a two-sector economy. Okay, so the example is a two-sector. Where industry A uses input from industry A 200 out of the total input that it utilizes 1000. So let's make that 400. So again, industry A buys from industry A 400. There are many companies in the same industry, so they could be buying from each other for different reasons. And then the next column, in the same column, industry A buys from industry B 100 units to make as their input, its input, out of the 1000 units of input. And you go on and on and on. But let's say we have only 2. We're looking at the relationship on 2. In the full input-output model, you would have to list all the matrices, all the input proportion that comes from each industry until it tallies equals to 1. But in this case, we only look at A and B, which is 400 and 100 of the 1000 units of input that A uses. Okay, now we focus on how much B uses as their input. So let's say they use 400 from A out of the 2000 units of input that they use. And B purchased from B 600 out of the 2000 that they purchased as input. right? So do you understand the relationship? B uses 2000, yeah, B uses 2000 units of input. Out of that 2000, 400 is purchased from A and another 600 is purchased from B, and so on and so on and so on. There should be C and D and so on. Same thing here. A uses a total of 1000 units of input, but purchase that input 400 from A and 100 from B. So the technical coefficient or the technical relationship of their input buying from each other will be 0.4 and 0.1. Here it will be 0.2, and this is 0.3. Okay, so you go downwards here and you collect the coefficients. So the next step is to find, we've already got the A, the technical coefficient. Now the next step will be to find the Leontief, which is the I minus A. It's also called the Leontief matrix. So since you have a 2 by 2 matrix, so you create a diagonal 2 by 2 to represent I, the minus, and you got 0.6. Okay, now let's say there is external or final demand which is 100 unit of A and 140 of B. Okay, so we will need to use this. So the D matrix will be 100 and 140. Okay, coming back to our solution, which is x equals to I minus A and D. Use the so use the formula for a 2 by 2 inverse. This 1 over then you switch the places, remember, you make this positive if it is negative, and you multiply with D, it is 100 and 140. Okay, we multiply this to then you multiply this column with this row, and then you multiply 98 0.4, multiply 0.4 with 94, and this will be your answer. In other words, the economy will have to produce So that's how you do the 2 by 2 open economy. If it is a 3 by 3 open economy, same thing, x equals to x equals to I minus A inverse, then we multiply with D. So to find I minus A, please use the Gauss-Jordan inverse method, where you have the I here, A and I, and upon solving by Gauss-Jordan, you should get I and I minus A here. Yeah, this I minus A is from the previous process, like this. So this is your I. So after going through the Gauss-Jordan on the right side, it would have been the inverse. So this inverse will be what you take, you lift and multiply with D. So that would be our solution. Okay, now we look at the closed economy. It means that the economic sector produce just enough to meet the demand for intermediate output. So it does not sell to the final users. It does not create any surplus. So in that case, we write X as equal to AX, with a certain, where A reflects the relationship between industries, but there is no demand from final users. So X minus AX equals to 0, Xi minus A equals to 0. So with this being there, you would have a very familiar structure where this is the coefficient matrix. Let's say you have 3 by 3, and on one side you have the constants, except that the constants here are 0, 0, 0. So this should be familiar to you. This is how we would solve. This is how we set up our matrix for solving. So you can take down whatever the matrix value of I minus A is now, so 0.6, 0.2, 1, 0.1, 2, and so on, so on, so on. as long as the right hand side is 0. So you can start solving and move on from there. Column cleared, and this column cleared, and this column cleared. Your answers will not be perfect. Yeah, let's say 1, 0, -1, 0, 1, 0, 0, 0, 1. And you can do the interpretation accordingly. So x minus z equals to 3. It means that x equals to 3 plus z. And then y equals to 4, and z should be all real numbers. So that's all for matrix. You can review these notes again and again. If you need any guidance, and you can try the questions at the textbook and also at the end of your course notes. Thank you.